So we'll look at a couple of questions. So here we have triangles ABC and SRT, and they are equal. And they ask you to fully label triangle SRT. So there's no proving with this. You don't need to have any statements with this. You just need to actually write them on. But let's have a look. So we are given a right angle here, which would match this one. And we are given RT, which is 4, which must match with the AC here. So going from the 90 degree, if we have 4 centimeters going off to the 37 degree angle, this angle here must be 37 degrees. So I'm going to write that on, 37 degrees. Now, looking again at the triangle on the left, the 5 centimeters is opposite the 90 degree. So here's my 90 degree, opposite that is line ST. So that line there will be 5 centimeters. As a check, we can look and go, okay, 37 degrees angle has got 4 centimeters and 5 centimeter sides. On the right here, my 37 degrees has got 5 centimeters and 4 centimeter sides, so they match. That just leaves one angle on one side. This side here must be 3 centimeters because it's the missing side. And if I want to work out, I should probably work out the missing angle as well, because it does say fully label. So I want this one here. And here it's probably worth writing the workings just to prove that the angle is the size you think it is. So we know that, what have we got here? We've got angle R plus angle S plus angle T will be equal to 180 degrees. Angle R we know is 90. Angle S we don't know. And angle T is 37. And they make 180 degrees. So angle S is going to be 180. Subtract 90, subtract 37. And if I do that, I'm going to end up with the answer, I think, of 53 degrees. So, moving on. Second example, we got a statement here that says that ABCD is a rectangle. Explain why triangle ABC is equal to triangle BCD. There's no picture here, so we'll have to draw a sketch. Let's just do a little sketch here of a rectangle. We're going to label it A, B, C, D. Be careful to make sure you label it going all in one direction. And there are triangles. So we have triangle ABC. And we have triangle BCD. So we get something that looks a little bit like the back of an envelope. And we've got to explain why they are equal. So I'm going to separate these triangles out. I'm going to redraw ABC. So ABC is going to look like this. Down here, A, B, C. And we've got triangle BCD, which looks like this. So it comes down here, along here, and over here. So I've got B, C, D. Now, we've got to prove that these two triangles are equal. Let's go back to our original triangle. We know it is a rectangle, so we know that the opposite sides of the rectangle will be the same as each other. We also know that all the angles here will be 90 degrees. Now, let's put these same marks on my two triangles. If we look at triangle ABC, we know that this corner is 90 degrees, and this length AB has got a double dash on it, and BC has got a single dash. On triangle BCD, we have a right angle at C. BC has got a single dash, and we know that DC has got the double dash. So looking now at my two triangles that I've drawn here, we can see that the angle is the same, both 90 degrees. They both have a side which has got a double dash, so these two sides are the same length. We know the other side has got a single dash, and these two sides are the same length. In fact, they are exactly the same length because they are both BC. So what statement should I write? Okay, well, I know that, let's have a look. We've got angle ABC equals angle BCD, and they equal 90 degrees. That's my first statement. I also know that AB equals DC. And I also know that BC will equal BC. It's the same line. So what statement do I put? I can say that an angle is identical in both triangles, and the sides around the angle are also identical. So A, B, C and B, C, D are equal. Remember, you have to put the arguments mathematically, the statement of the rule you're using, and then the final statement to say they're equal. And with a complicated question like this, draw the triangles separately, label them, and then you can see pretty clearly what is the rule you're going to be using. Okay, finally, this one looks really tricky. We've got ABC is an equilateral triangle, so that's the little one in here. That's equilateral. Explain why triangle DEF is equilateral. So explain why the big one is equilateral. This is probably more difficult than what you'll get in your assessment. Let's have a look. ABC is equal, so I'm just going to draw on here that these sides are all the same. Because if it's equilateral, they must all be the same. I also know, if they're all the same, that this angle here is 60. So I'm going to write in 60 on each of these angles. Now I know that that's 60. If I just zoom in on this, I also then know what this angle must be, because I have a straight line. If you look, I have a straight line here. This is 60. This angle added to this one must make 180. So let's go back out again and let's have a look. What can I write for this? So I know as a statement that angle CAB, that's this angle here, plus angle CAD, that's this angle here, must equal 180 degrees. CAB is 60, so 60 degrees plus CAD equals 180. CAD equals 180. Take away 60, which is 120 degrees. So I know that that angle is 120 degrees. I'm going to write it in blue. Clearly, that's going to be repeated around the shape. This is going to be 120 degrees, and this is going to be 120 degrees because they are all the same. They are straight lines with 60 degrees. So I'm going to put that as a statement here. I'm going to say that angle CAD equals angle DBF, and it equals angle ECF, and they all equal 120 degrees. Now, what can I do with this now? Well, if you look at one of these triangles, I'm going to redraw just one of them. I'm going to redraw DFB. Doesn't have to be a great sketch. DF and B. Now, this has got the length of a one dash here. This has got a single dash here, and there's a little bit here, and there's a double dash. And this angle here is 120 degrees. Well, if you look at my triangles, what I've actually got here is I have three triangles here. This one, and this one. And this length here is made up of a single dash and a double dash line. This one here is made up of a single dash and a double dash, and this is made up of a single dash and a double dash. So these lengths are all equal. I think it's a fair statement to write that straight down and say that DB equals EA equals FC. So those are all the same length. Plus, we know that in our triangles, these short lengths here, this one, and this one, and this one are all the same length. So we know that, what have we got? We've got BF equals, what have we got? We've got DA equals CE. So that's a statement saying that all these three lengths are the same. The first statement was that these longer lengths are the same. And then you know the angles in between are also the same. We've written that already here. So we have an angle with its two sides are identical. So for triangles BFD, EAD, and ECF, an angle and its two sides are equal. So the triangles are equal. So if the triangles are equal, that means that the other sides are equal. DF must equal EF must equal DE. So let's put that one in. So DF must equal FE must equal DE. So we have three sides the same length. So we know our triangle, those three sides are all the same length. And if we look at the triangle, what have we got? We've got missing angles here. This angle and this angle and this angle must be equal to each other. We know that, marking in green, we have this angle, and this angle must be equal to each other because our three little triangles are equal. So the three angles are all the same. So we got a red and a green, a red and a green, and a red and a green in each corner. So we know that EFD, this is getting awfully messy, EFD is equal to FDE. I should put angles on here. Angles EFD equals FDE equals DEF, I think is the other one I haven't got, so DEF so DEF is an equilateral triangle. Now, this question is more complicated than what you're going to get in your test, but the steps are the important thing, the logical process. If you have an image and you're not sure what to do what you can from the information you are given. I knew that it was an equilateral triangle in the middle, so therefore I labelled it. And once I started labelling, I could see that there were missing angles I could work out. And once I did that, I knew that was repeated round, and then I started to build up my answer as you went through. So take a time to study that. Don't get too worried about it, but it's worth having a little look at seeing how it was built up. Now, the best revision you can do is to redo the questions that we've done in class, okay? So some of the earlier questions are probably more important. These ones are slightly more complicated than you're going to get in the exam. And finally, don't panic. You've all shown in class that you can do this work. Make sure you spend some time this weekend doing some questions, and good luck for the exam. If you do have any more questions, please drop me an email.